According to some researchers, our universe is moving towards disorder. The universe will end in heat death, meaning everything in it will reach the same temperature where they can become no colder. The universe will become a dispersed soup of particles and radiation. In this theory, the universe ends up uniformly cold and empty. So what does all this mean? The second law of thermodynamics can be notoriously difficult to wrap our heads around. Be that as it may, this fundamental law is arguably one of the most valuable concepts in science. The laws of thermodynamics help us understand why energy flows in specific directions and in certain ways. Thermodynamics can be used to explain why your coffee loses heat while sitting on your desk, how an engine functions, how energy transfers occur in biological systems, and possibly even how our universe will end. A lot of the ideas described by thermodynamics seem like common sense. However, these laws are underpinned by a mathematical framework that makes them powerful for describing systems and making predictions. We will skip the math today and focus on the core concepts with the majority of our attention directed towards the second law. There are three main laws in thermodynamics. The first law of thermodynamics applies the conservation of energy to heat and thermodynamic processes. The principle of conservation of energy states that energy cannot be created or destroyed. It only moves from one form to another. The first law states that the change in the internal energy of a closed system is equal to the heat energy added to the system, minus the work done by the system. Note that this is for a closed system. For systems where there is a transfer of matter, a different definition is used. In such systems, energy is continually being transformed into different forms of energy. But this transformation is a one-way street. The direction in which energy moves from one form to another can be described using the second law of thermodynamics. Entropy, often popularly defined as disorder, lies at the heart of the second law. It can be defined as a thermodynamic quantity representing the unavailability of a system's thermal energy for conversion into mechanical work. The second law has been expressed in many ways. One is that in all energy exchanges, if no energy enters or leaves the system, the potential energy of the end state will always be less than that of the initial state. Another way of describing this is that energy will move from a state of lower entropy to a state of higher entropy. Thus, a closed system will always move towards a uniformly disordered state. So what does all this mean? And how does the second law directly impact our daily lives? This morning, you may have poured yourself a cup of hot coffee. As your cup of coffee sat on your table, it began to lose heat. Heat flowed from the hot coffee cup into the environment because the heat energy dispersed. It moved from a state of less entropy to one of greater entropy. Here, entropy explains why heat energy flows from hot to cold and not the other way around. The second law of thermodynamics is useful for describing a huge number of processes in fields like cryogenics, chemical engineering, biology, automotive engineering, computer design, aeronautics, astronautics, and mechanical engineering. It is everywhere. It can even be used to help predict the end of the universe. According to some researchers, our universe is moving towards disorder. The universe will end in heat death, meaning everything in it will reach the same temperature where they can become no colder. This state will occur when all the energy in the universe is evenly spread out. The universe will become a dispersed soup of particles and radiation. The expansion of the universe will drain even the energy of that soup over time. and this will leave everything just a fraction of a degree above absolute zero. In this theory, the universe ends up uniformly cold and empty. Thankfully, this will happen far, far off into the future. In what ways do you think the second law of thermodynamics affects your life?